Hello and welcome to screencast for the Chapter 2 note page for IM2. So today I'm going to go through the questions with you on the IM2. So you're going to go into week 2 and you're going to open the note page. If you have access to a printer, you can print it. If you don't have access to a printer, you can just write all your answers on a piece of paper and submit it your notes through Schoology, or you can open with Kami. Kami is an extension that allows you to write on top of a PDF. And I'm going to use the tools over here to the left. So I'm going to use a text box, and up here I'm going to type in the name of the tool I'm using. It's called Kami Extension. So if you want to search that and use that, you can. So we're going to do page 1 today. So the first question says, list the 5 triangle congruence theorems. And so the first one we're going to list is called, and I'm going to use orange. Why not? Okay. We're going to use side, side, side. Orange doesn't show up really well, so let's change it to green. Okay. Then I'm going to use side, angle, side. We also have angle, side, angle, 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 side, and there's a special one called hypotenuse leg. All right. Over here it says, what is the purpose of the 5 theorems listed to the left? And so the purpose of those 5 triangle congruence theorems is to prove that 2 triangles are congruent let's drag this down. Return. Using their sides and their angles. Okay. So remember that each of the 2 triangles has 3 sides and 3 angles. So you're going to compare each of those. And then, oh, that doesn't look good. Let's move down here so you can see it. There we go. All right, question number 2. It says, list the 3 triangle similarity theorems. Okay, so similarity is different than congruent. So congruent means that they have equal measurements. Similarity means that they're similar. Okay, so similarity has angle-angle similarity. It's the similarity symbol. It's there. There's another one called side-side-side similarity. And then there's one called side angle side. Oh, didn't type. Side angle side similarity. All right. All right. Explain what the following statements mean in your own words. So if the corresponding angles are congruent, that means the angles that match up have the same measurement. All right, so let's drag that down here. And I spelled match wrong. Okay. And then what, in your own words, what does it mean to have corresponding sides that are proportional? So the matching sides can be set up in a proportion. And then proportions can always be solved by doing the cross product and then seeing if it's true. So if you get 36 equals 36, great, then they're proportional. But if you get 36 equals 32, then you say, nope, they're not proportional. All right. Question number 3 says triangle congruence. Triangle ABC is congruent to triangle GET. So they want us to draw two triangles using the statement above and mark their angles and sides as congruent. So I'm going to come down here and I'm going to grab a shape. So I'm going to grab a line. And so I'm apparently using blue. Okay. So I'm going to draw a side right here. Why not like that? And then connect those two endpoints. There's one triangle. Now I'm going to do another triangle. Let's use purple. Okay. So it's just a rough sketch. It doesn't have to be exact, but they basically look the same, sort of. I did pretty decent for me. Okay, so let's use green, and we're going to call this one A, and then B, and then over here, we'll go C. Okay, so there's triangle ABC. It's congruent to triangle GET. So the same order that I went in here on this blue triangle, I need to go in the same order on the purple triangle. So I'm going to call that one G because that letter came first. And then this vertex is E because that one came second. And then this vertex T because that one came third. Okay, they want us to mark their angles and sides as congruent. Okay. Do they want, okay, so we're just going to list, because they've already put the congruent symbols in here for us, so which angles match up. So angle A obviously matches to angle G. So we're going to say angle A, there is a little symbol, okay, angle A is congruent to angle G, angle B is congruent to angle E. And what do you notice? You're noticing that it's the same order in the between the two triangles. Okay, so the third one is angle C is congruent to angle T. All right, now we're going to match up sides, and I just go in order, so from A to B. So for right here, I'm going to put side AB, and the same corresponding side down here is GE. Then I'm going to go across the bottom, B to C, so I'm going to say BC corresponds to ET. And then the one that's left is C to A. So we're going to say side CA is congruent to side TG. And we have matched up all the corresponding angles, 3 pairs, and all the corresponding sides, three pairs. Okay? Question number 4 says triangle similarity. This time, instead of the two triangles being congruent, we have the little similarity symbol in here. Okay, so it says draw triangle GET and dilate by a factor of 3. So this number 3 is larger than 1. Okay, so if it's just a dilate by 1, it would keep the triangle the same size. But if it says to dilate by 2, it's going to double it. If it says to dilate by 3, it's going to triple it, and so forth. But if your number of what they call K factor is less than 1, say it's 1/2, it's going to shrink it. Okay, divided by 2. If it's 1/3, it's going to shrink it by 3. Okay, so whenever this number is larger than 1, it's going to get larger. And so we need, if we were going to draw this to scale, we would need a triangle that's way larger, but we don't have enough room. So I'm just going to come over here, grab a shape. I'm going to grab the line. Let's go with this bright green here. Okay. So I'm going to try and make it look like triangle ABC as much as I can. It's not going to be perfect. Rough sketch is fine. And then I'm going to label the vertices like they asked me to. Let's use red. So we'll call this vertice over here, because it's going to match with A, we need to call it G. And then this vertice right here is going to match with C, so we'll label it T. That means the third one down here has to be E, right? Okay. So now we've got our three sides. So we want to dilate by a factor of 3. That means we're just simply going to multiply by 3. So let's do this longer. Well, it looks longer, but it's obviously not drawn to scale. This side over here that says 3, 3 times 3 is, dun, 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 9. Okay, oh, let's do another color, because red, we did the vertices in red, so let's go with orange. Nah, oh, I don't like orange. How about purple? Yeah, purple. Okay, this side over here, TE, is matching up with BC, or CB, so 5 times 3 is, dun, 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 15. And the last side over here, I think that's a 4. So we're going to multiply 4 times 3, which is 12. Okay, oh, and we don't need to hit return. Okay, so they want us to write or compare the corresponding sides. So they just want us to write the ratio of the side to the side. So since they went A, B, C, I'm going to do A to B first. And that gets compared to G to E. And then B to C. And that gets compared ET. And then C to A gets compared T to G. And then we're just going to squeeze in our measurements. So that's going to be 9 to 3. So I'm using the line they gave me as my fraction bar. BC is 3 to 15, okay. C to A is 4, and T to G is 12. All right. Oh, how did I mess up something? Well, that's A to B. Did I do those backwards? A to B was 3, so, oh, so my 9 and my 3 should be switched. Okay. All right, there we go. All right, question number 5 and 6 is a flow chart. We do not need to do those. We can skip those. So we're going to put the word, I'm going to use the pencil. Let's use the pencil. We're going to write skip. Skip. They're really together, so if you would like to do them, you can. You don't have to. And if you used Cami, like I just did, you would click turn it in here, and then you would be taken into Schoology, and from there you would hit submit. All right.